Hello viewers, today I will teach you some basic theorems, mean value theorems. There are three mean value theorems: Rolle's theorem, Lagrange's mean value theorem and Cauchy mean value theorem. Among these three, the mean value theorem means the generalized mean value theorem, which is the Lagrange's mean value theorem. Lagrange's mean value theorem is generally known as generalized mean value theorem or simply mean value theorem. So now look at here, Rolle's theorem. Mean value theorem means Lagrange mean value theorem. Lagrange mean value theorem means mean value theorem. Cauchy mean value theorem. So these three are actually mean value theorems, but this is the generalized mean value theorem. Now I have written here the three theorems comparatively. I want to compare these three statements. First is Rolle's theorem. If a function f of x is continuous on the closed interval AB and differentiable on the open interval AB. So, in order to satisfy Rolle's theorem, the function f of x should satisfy first these two conditions. It must be continuous on the closed interval and differentiable on open interval. And third condition is f of A is equal to f of B. That means in that interval, the value of the function at A is same as the value of function at B. So, if any function satisfies these three conditions, then there exists a point C on the interval AB. In between A and B, there is a point C where f dash C is 0. F dash C means first derivative at x is equal to C. Suppose this is the interval A, B. We can find a point C in between these two. Suppose C is here, where the first derivative can be 0. So this is the statement of Rolle's theorem. And the statement of mean value theorem or Lagrange's mean value theorem is, if we compare these two theorems, then the first two are same. Means if a function f of x is continuous on a closed interval AB, differentiable on open interval AB, the first two conditions are common. If any function satisfies these two conditions, then there exists a point C in between A and B. In between A and B, there is a point C where the first derivative f dash C is equal to f of B minus f of A by B minus A. Compare these two. Here, C is a point in between A and B. C is a point in between A and B where in Rolle's theorem f dash C is 0, but in Lagrange's theorem f dash C is equal to f of B minus f of A by B minus A. So this is the statement of mean value theorem. And another is the Cauchy mean value theorem, where we need two functions f of x and g of x. And these two functions f of x and g of x satisfy that these two functions are continuous on AB and differentiable on AB. So among these three theorems, the first 2 points are common. The functions must be continuous on the closed interval and differentiable on the open interval. Any two functions f of x and g of x satisfy these two conditions, then there is a point C in between A and B. We can find a point C between A and B where f dash C by g dash C is equal to f of B minus f of A by g of B minus g of A. So look at here. This mean value theorem is extension of Rolle's theorem. This can be derived from Rolle's theorem, and this also can be derived from here. Look at here. If f dash C is f of B minus f of A by B minus A, then what will be g dash C? G dash C will be g of B minus g of A by B minus A. If we divide f dash C by g dash C, we can find this. So this Cauchy theorem is the extension of mean value theorem. So this is the statement of three theorems. Geometrical representation of mean value theorem. First is Rolle's theorem. We know Rolle's theorem is if f of x is continuous on AB, differentiable on open interval AB, and f of A is equal to f of B, then there exists a point C belongs to AB where f dash C is equal to 0. Look at here, how can we represent, what is the geometrical representation of Rolle's theorem? Look at here, this is the curve y is equal to f of x. This is the function y is equal to f of x. And suppose a point is here A and a point is here B. And this function, according to this theorem, the function is continuous. Look at here, from A to B, the function continues. So this continuous and is also differentiable. Suppose this is differentiable. Now, f of A, look at here, this is the value of f of a and this is the value of f of b. And from this figure it is clear f of a is equal to f of b. That means this curve satisfies the three conditions of Rolle's theorem. Now what happens? We have to find a point C. Suppose a point is C here. C belongs to AB. C belongs to AB. Suppose C is here. Now at C, the value of f dash C means the first derivative at C is 0. Means at C, I join here. This is a point where at this point P, this PT is tangent to the curve. PT is the tangent to the curve. So if PT is tangent to the curve, then slope of PT means tangent, slope of a tangent at C, slope of a tangent is a derivative. That means this is derivative of f of x at C, which is f dash C. But according to theorem, if any function satisfies these conditions, then f dash C is equal to 0. That means f dash C is equal to 0. Means slope of tangent at C is equal to 0. So the geometrical representation is, if any function satisfies these three conditions, then there exists a point C between A and B where the slope of a tangent is 0. Slope of a tangent is 0. But we know slope of x-axis is 0. That means slope of x-axis and slope of a tangent line is same. So if these two slopes are equal, and we know if the two lines have same slope, then they are parallel. That means this tangent is parallel to x-axis. So the geometrical representation of Rolle's theorem is, if any function satisfies these three conditions, then there exists a point C between AB where the tangent is parallel to x-axis. Now geometrical representation of Lagrange's theorem or mean value theorem. The condition of a mean value theorem is, if a function f of x is continuous on open interval, is continuous on closed interval and differentiable on open interval, then there exists a point C belongs to AB. In between AB and B, there is a point C where f dash C is f of B minus f of A by B minus A. Here, suppose this is the curve y is equal to f of x. Suppose the point A is here and the point B is here. So now the coordinate of this point, this is suppose P and this is Q. Now the x coordinate of this point, we know the coordinate of a point is xy, means xy is equal to f of x. At this point the x coordinate is A and y coordinate is f of A, means this point has coordinate A f of A. Similarly the coordinate of Q is the coordinate of Q point is B f of B. Now join PQ. So PQ is the chord or secant. So slope of PQ is equal to, by 2-point form is y2 minus y1 by x2 minus x1, means f of B minus f of A by B minus A. Suppose a point C is here. We have to find a point C between A and B. So C is a point between A and B. Now if this point is C, now at the point C the tangent to the curve is like this. Suppose this is RT. Now RT is the tangent. RT is tangent to curve at x is equal to C, and the slope of tangent RT, slope of this tangent, we know slope of tangent means derivative. So this is the derivative of that function at x is equal to C, which is f dash C. But according to mean value theorem, we have f dash C is equal to f of B minus f of A by B minus A. So we find slope of a tangent is equal to slope of a chord PQ, which implies geometrically Mean value theorem represents as these two are equal, this is slope of tangent and this is slope of a chord. So slope of a tangent is same as slope of a chord. If these two lines have same slope, that means these two lines are parallel. So tangent at C is parallel to chord PQ. So this is the geometrical representation of a mean value theorem. Rolle's theorem represents the tangent is parallel to the tangent at C is parallel to x-axis, but here the tangent is parallel to the chord joining P and Q. The memory capsule, become a technical guru, how to apply these theorems, and in exam you can apply the theorems in the 4 ways. First is to write the statement, second is geometrical representation, third is the verification, that means a question will be given and you have to verify that whether the theorem, Rolle's theorem or Lagrange mean value theorems, whether the mean value theorems are verified or not. That fourth is the test of applicability, means you have to test whether mean value theorems are applicable or not to a given function. A function will be given, you have to test whether the mean value theorem are applicable or not to that given function. So in this section, mean value theorem section, you will find these 4 types of questions in all exams. Now how to verify? A question is here, verify Rolle's theorem. The first question, verify Rolle's theorem for the function f of x is equal to x square plus 2x minus 8 for x belongs to the closed interval minus 4 2. Here the given function is f of x is x square plus 2x minus 8 and the closed interval a b is given minus 4 2. A is minus 4, b is 2. So in order to satisfy, in order to verify whether Rolle's theorem is verified or not, we have to show the 3 conditions. F of x is equal to x square plus 2x plus 8 and f dash x means derivative is 2, f dash x means derivative with respect to x, 2x plus 2. That means f dash x is a polynomial. So if this is polynomial, the value of this polynomial exists for every real number. That means f dash x exists on the closed interval minus 4 2. So if this function, if f dash x exists, then that means f dash x exists. So f dash x exists on minus 4 2. If f dash x exists, that means f dash x exists means f of x is differentiable on minus 4 2. And we find the first condition. If f of x is differentiable, we know every differentiable function is continuous. So if f of x is differentiable on minus 4 2, then we find f of x is continuous on minus 4 2. And second condition is, if f of x is differentiable on closed interval, then it will be differentiable on open interval. So f of x is differentiable on minus 4 to open interval. Open interval means omit minus 4 and minus 2. That means every point within minus 4 and 2. And the third condition is to show f of a is equal to f of b. Now f of a means f of minus 4. Put here minus 4, that means it is 16 plus minus 4 means minus 4 16 minus 8 minus 8 is equal to 0, and f of b is equal to, b is here 2, f of 2, put 2 here is 2 square is 4 plus 2 into 2 4 minus 8 is equal to 0. We find f of a is equal to f of b. So third condition is we find f of a and f of b two are same. That means f of a is equal to f of b. So the given function f of x satisfies the 3 conditions. Now the important thing is, here the given function satisfies the 3 conditions, but the main aim is we have to find a point between minus 4 and 2 where the first derivative is 0. Look at here the very important thing. Between minus 4 and 2, we have to find a point C we have to find a point C between minus 4 and 2 where f dash C is 0. But dear students, minus between minus 4 and 2 in this interval there are lots of points, many points, minus 4 to 2. But how can you find a point between minus 4 and 2? Look at here, suppose here is minus 4, here is 2. There are many points. How can you find a point where the first bit is 0? So we can't find a point to show first bit 0, but we can show. How can you find a point? Look at here. First find f dash c. First find f dash c and equate this f dash c to 0 to find c. Remember, first find f dash c, equate this to 0 to find c. Look at here. So in order to find f dash c, we have f dash x is equal to 2x plus 2, which implies if f dash x is this much, then f dash c is equal to, put x is equal to c, that means 2c plus 2, and equate this to 0. First find f dash c, equate to 0, which implies we find 2c is equal to minus 2, implies c is equal to minus 1. Look at here, this c is equal to minus 1, which lies between minus 4, c is equal to minus 1, which belongs to minus 4 to open interval. So we find a point. So the first derivative is 0 at a point minus 1, and that minus 1 is minus 1 lies between minus 4 and 2. So there exists a point between this interval where the first derivative is 0 and the Rolle's theorem is verified. Next is test of applicability. The question is to test whether Rolle's theorem can be applied to this function or not. The given function f of x is mod x on the interval minus 1, 1. Now, how can test the function? How can test the Rolle's theorem can be applied or not? Now, given f of x is equal to mod x, we have test the three conditions. The first condition is the function should be continuous. We have f of x is mod x is f of x is not differentiable at x is equal to 0. I have already proved mod x is not differentiable at origin. That means this function is not differentiable at x is equal to 0. So 0 belongs to minus 1 to 1. So in order to show that the Rolle's theorem is applied, that means the function should be differentiable at every point within this interval. 0 is a point between minus and 1. 0 is a point between minus 1 and 1. This is number line, minus 1, 0, 1. 0 is here, but the function is not differentiable. That means the function is not differentiable within this interval. So as this function is not differentiable, that means this function on this interval does not satisfy all conditions of Rolle's theorem. So Rolle's theorem cannot be applied. Another question is f of x is equal to bracketed x on minus 2 to 2. We have to show the test of applicability. That means whether Rolle's theorem is applicable or not. F of x is bracketed x, the greatest integer function, but the bracketed x or the greatest integral function, is not continuous at the integral points. That means here the function f of x is not continuous on the integral points, means here minus 2, minus 1, 0, 1, 2. So if this function is not continuous at this point, which implies we know every differentiable function is continuous. If it is not continuous, then it will not be differentiable. So f of x is not differentiable on open interval. That means Rolle's theorem cannot be applied. Next is f of x is equal to sin x on x is equal to 0 to pi. We have to test the applicability. That means whether Rolle's theorem is applicable or not to the given function. F of x is equal to sin x means f dash x is equal to cos x, which implies f dash x exists f dash a, which implies f dash x exists on 0 to pi. That means if we take any value between 0 and pi, then we can find the value of f dash x. So if as f dash x exists, that means f of x is differentiable on 0 pi. As this is differentiable, then f of x is continuous on 0 pi, because we know that every differential function is continuous. And second is f of x is differentiable. Look at here, f of x is differentiable on closed interval, so f of x can be differentiable on open interval. And the third thing is to show f of a is equal to f of b. Now f of a means f of 0, that means f of x is sin x, f of 0 is equal to sin 0, which is 0. And f of b is pi, that means f of pi, which is sin pi, is also 0. That is, third condition is we find f of a is equal to f of b. Look at here, f of a, f of b equal हो गए. So here the function f of x equal sin x satisfies all the three conditions of Rolle's theorem. As this function satisfies three conditions of Rolle's theorem, so Rolle's theorem can be applied. So Rolle's theorem can be applied. Another important question, verify mean value theorem if f of x is equal to x square minus 4x minus 3 in the closed interval a b, where a is 1, b is 4. Now look at here, given function f of x is x square minus 4x minus 3 and the closed interval a b is 1, 4. Now here, the students, in order to verify mean value theorem, first we have to show that the function is continuous on the closed interval and it should be differentiable on the open interval. Now here we have f of x is equal to x square minus 4x minus 3. So f dash x is equal to 2x minus 4. And f, which implies f dash x here is a polynomial. That means the value of this polynomial exists for every real number. If we take any real value of x, then the value of f dash x exists. So if f dash x exists for all real values of x, then f dash x exists on this interval 1, 4. If f dash x exists, that means f dash x exists means the function f of x is differentiable. So f of x is differentiable on the closed interval on a b. But we know that if a function is differentiable, then it must be continuous. So according to this theorem, this function f of x is continuous on the closed interval a b. This is the first condition. And the second condition is, look at here, f of x is differentiable on the closed interval. If f of x is differentiable on closed interval, then this function f of x is differentiable on the open interval. So the two conditions of mean value theorem are satisfied the function. Now we have to find a point C between. Now we have to find a point C on the open interval a b, where f dash c is equal to f of b minus f of a by b minus a. I have already said the trick in Rolle's theorem that you can't find a point between 1 and 4 which will satisfy this condition, but it will be better find f dash c, then find f of b minus f of a by b minus a, equate this f dash c to this f of b minus f of a by b minus a to find c. So the trick is, first find this value, find f dash c, equate this to find c. So look at here, we have f of a means a is here 1, f of 1, put here f of x is this much, so f of 1 is 1 minus 4 minus 3, this is 1 minus 7 is minus 6. F of b is equal to, f of b means b is here 4, f of 4, put here 4 square is 16, minus 4 4 is 16, minus 3, so this is minus 3. Now we have to find this f dash c, now we have to find this f of b minus f of a by b minus a, which is equal to f of b is minus 3 minus f of a is minus 6 plus 6 by b minus a is 3. So this is equal to 1. Now to find f dash c, here f dash x is now f dash c, f dash x is equal to 2x minus 4. So f dash c is equal to put x is equal to c, 2c minus 4, 2c minus 4, and f dash c is equal to this much, that means 1. So this 2c minus 4 is 1, which implies 2c is equal to 5, which implies c is equal to 5 by 2, that means 2.5, which belongs to 1/4. So after equating f dash c is equal to f of b minus f of a by b minus a, we find a point c which belongs to this open interval. So that function f of x on the interval 1/4 satisfies the two conditions, and also we find a point c in between that interval 1 and 4 which satisfies f dash c is equal to f of b minus f of a by b minus a. Hence mean value theorem is verified.